welcome you all. In last sessions, we have discussed about malloc and cloc functions. In this session, let us discuss the next function of dynamic memory allocation, that is free. In previous two functions, we were allocating the memory for the variables, but in this function, we will clear that memory or we will vacate that memory whatever we have allocated by using the malloc and cloc functions. So for that we use free function. Okay, so free function, it vacates or clears off the dynamically allocated memory after some time when it is not more required. So okay, any limitation on available memory size can be overcome during runtime if we use free function. That means if we require any memory that is needed urgently, means if we use the free function, that will get all the memory locations which are not used by the processor. Okay, the syntax for this is free PTR, free IPTR, free CPTR, free SPTR. Like this we can free the memory locations. Here the pointer variables PTR, IPTR, CPTR, SPTR, etc. are all associated with memory blocks that are already we have discussed in the previous session, that is malloc and cloc and realloc functions. Next, let us see the example program of how this free function frees the block of memory allocated by cloc function. So here I have declared I, j and k n normal variables and int star array is the pointer variable, then CLR SCR, printf enter the number of elements of array, scanf percentage %t, ampersand of n. Here n is the number of elements of array. Here I'll allocate the memory by using cloc function, that is array is equal to int star cloc n size of int. If array is equal to int of null, then print error out of memory. That means there is no memory in the system, then exit 0. If that is false, then printf address of located memory, that is what is the address located to the array, that we will be printing. And next printf enter the values of %d array elements, that is n. Then for j is equal to 0, j less than n, j plus plus, scanf %d ampersand of array of j. That means we are inputting the array elements for this array. Then printf address of first number, then printf address of second member, array plus 1, then size of array, that is %u, n star size of int. Then for I is equal to 0, I less than n, I plus plus, then printf array of, that is array plus I. That means here we will be printing the array elements, then we will call the free function, free of array. Here array is the variable which has the starting address of the whole array. Then printf after the free action of free, the array elements are for k is equal to 0, k less than n, k plus plus. That means after using the free function, we will print the array, then printf array of a %t, then that is equal to %t k star of array of plus I, then return 0, then closing bracket. Now let us see the output of this program. So this is the output for this above program. Here enter the number of elements of array, that is 4. Address of allocated memory is 2190. Then enter the value of 4 array elements 10, 20, 30, 40. Then address of first number is equal to 2190 and address of second member is 2192. Then size of the array is 8. Then array of 0 is equal to 10. Array elements will get printed like 20, and that is 10, 20, 30 and 40. Then after the action of free, then the array elements becomes a of 0 is 5, a of 1 is 5, and a of 2 is 5, and a of 3 is 5. Okay, so like this we can free the memory locations in the programming. Okay. Next, let us see the next function, that is realloc. Here this function will changes the size of the previously allocated block of memory by malloc and cloc functions. Okay, so here realloc function, it modifies the size of the memory memory block by using malloc or cloc function or by itself also. The syntax becomes like this: void star realloc, void star ptr size t size. Here ptr points to the memory block obtained by the previous call of malloc. Here cloc and realloc and size represents the new size of the memory block. That means we are using reallocate for the alteration of the size now. So that's why it represents the new size of the memory block. That is cloc or realloc. Okay. Which then suppose the new size is larger and enough free memory is present immediately after the previous allocated block. In that case, its old contents remains unchanged and the additional memory is added to the block's end. Here this function does not initialize the bytes that are added to the block. If the new size is more extensive and sufficient space is not available after the block, then realloc allocates a new block of right size. That means if you don't have the required size of realloc function, then it redesigns the new block which is required for that realloc function. Then it copies the contents of the existing block to the newly allocated block. This function will also copies the previously allocated contents to the newly allocated block. And on the other hand, if the size is smaller, the memory block contents are preserved up to the lesser of the new and old sizes. That means if the size is smaller, the memory block contents are preserved up to the lesser of the new and old sizes. If the requested block of memory is unavailable, it returns a null pointer. That means there is no null means there is no memory available in the CPU, okay, and or the memory block. Then the data in the old memory block is unchanged. It remains as it is. In case the first argument of the realloc is a null pointer, then it behaves exactly like malloc. That means it creates a new block of memory. If the second argument of realloc is 0, then it frees the memory block and null pointer is returned. Let us see the example of realloc function. Here hash include stdio.h, hash include stdlibrary.h int main. Here I have declared one array pointer, that is star arr. I, n1 and n2 are the normal variables. First printf enter size, then scanf %d comma ampersand of n1. Then here I will create a block of memory by using the malloc function, that is arr is equal to int star malloc n1 star size of int. Then printf addresses of previously allocated memory. For that I use for loop. For I is equal to 0, I less than n1, I plus plus printf percentage u comma arr plus I. Then printf enter the new size. Then scanf percentage d comma ampersand of n2. Here we will reallocate the memory blocks. For that I use realloc function. Arr is equal to realloc arr comma n2 star size of int. Then printf addresses of newly allocated memory. For that I use for loop. For I is equal to 0, I less than n2, I plus plus printf percentage u comma arr plus I. Then free arr return 0 closing brace. Here the output looks like this. Enter size 4. Addresses of previously allocated memory, 4 addresses displayed, that is 19386384, that is system, it depends on the system, and second address is 19386388 and 19386392, 19386396. Like this the addresses of previously allocated memory will get displayed, and after reallocating, that is enter the new size 6. Now the addresses of newly allocated memory, the previous 4 addresses remains as it is, and the next 2 blocks of memory, that is 193864000 and 193864004, these 2 blocks of memory will join to the previously allocated memory, and now it displays the addresses of all 6 memory blocks like this. Now let us see the differences between malloc and cloc. In cloc, it initializes the allocated memory with 0 value. In malloc initializes the allocated memory with the garbage values. That means during the initialization of the CLOC function, the allocated memory value will become 0, but in malloc the allocated memory value will become garbage value. In CLOC the number of arguments is 2, you can see in the syntax, and in malloc number of argument is 1. The syntax of CLOC is cast type CLOC, 2 arguments are blocks comma size of block, but in malloc cast type malloc size in block. So like this we can write the differences between the malloc and CLOC.